Okay guys, I think we can now start. Other people will join. Just remind you that if you go to the description of the stream, if you go to the description of the video, then you will find the question, this question, and you will also find the summary. So the summary is also in the description for those that don't have it or want to go back to the summary. Both of them you will find it in the description of the video. There's a link where you can get both of the documents, the question itself and the summary. It's important because we need to use the summary to help you with the definition. You can see the Newton's first law, Newton's second law, forces, definition of forces, etc. So it's an important summary. Let's go to the question. Let's answer the question. I hope you did answer this question before you join. It is important to do that, to try to do it before you join. Okay? So the question say a block of mass 4 kg resting on a rough horizontal table is connected to another block B of mass 8 kg by a light inextensible string which passes over light frictionless pulley. A force of magnitude 96 Newton is applied vertically upward on block B. And then here you have the picture. So you have a block A here, and the block A is connected to B through a rope, and then somebody is pulling B upward, as you can see there. Now they are giving you the kinetic frictional force for A. So there you will see a kinetic frictional force that is acting on A. A is the one that is on the surface. B does not have a surface. Okay, and that frictional force is 11,76 Newton. Ignore the effect of a friction. Question 5.1, state Newton's second law of motion in word for 2 marks. Make sure you get that one. It is in the summary. If you can see, here is Newton's second law of motion from this point here. That is the definition. It is in the summary. Try to get the summary. I will post it as well in the channel itself. They say when a resultant net force acts on an object, the object will accelerate in the direction of the net force. An acceleration which is, let me just get this one here, there we go. The acceleration is directly proportional for the net force, and then you will get 1 mark for saying that one is the first mark, and inversely proportional to the mass of the object. That is the second mark. So there's 2 marks for saying that one there. Okay, so there's 2 marks for the definition. You have to learn the definition because those are the easy marks, or the easiest mark you can possibly get. The question say 5.2, draw a label-free body diagram for block B. So we have to draw a free body diagram for block B. Okay, so let's do that one here, and then let's put the picture so you can see and have an idea of what is going on here. We're going to use the same free body diagram to solve the upcoming question. So we're going to do here, that one was question 5.2, and we are going to solve the free body diagram for A. All right, now what forces are acting on A? You can see here in the picture that they are a rope, there is friction, we already spoke about friction, there is normal and there is gravitational force. It's quite simple. The forces that are acting there are the tension to the right, this is tension force, there is gravitational force straight down, there is normal straight up, there is normal because there is a surface, and then there is as well frictional force. There is frictional force. Those are the four forces that are acting on this specific I'm looking for this one here. Those are the four forces acting on block A. All right, you will get 1 mark per force. If there are 4 marks, it means there must be 4 forces. If there are 4 marks, it means there must be 4 forces. Okay? So let's go to do the free body diagram for the other object, because we also need it. We also need the other object. So let's take this this picture and move it here so it's out of the way, because we're going to use both blocks for the next upcoming question, and I'm going to use the same drawing, the same free body diagram. For the second object, which is this one here, the 8 kilogram block, you have that is an acting force pulling the block to top or up. This one is going to be the applied force. There we go. And the downward is 2 forces, or there are 2 forces. One of them is gravitational force, and the other one is tension, and I'm going to draw it along the same line. That is the tension force. You don't have to draw it along the same line. If you want, you can draw one next to the other, but they are both of them straight down. Okay, I have seen that most of the people just draw, for instance, gravitational force, and then next to it they draw the tension. As long as both of them are pointing down, straight down, that is correct. So you can use either one. All right, I prefer to draw it along the same line. Let me erase that one. There we go. Now that one was not part of the question, but we are going to need it just now. We don't need this picture for now. We don't need that picture for now. Okay, so that was the free body diagram for 4 marks. This one is here. There were 4 marks for free body diagram. You need those 4 marks, so make sure you don't make a mistake with those 4 marks. I hope there is not a question. Let me just look. If there's a question, you can just ask the question. Okay. Okay, there's no question, then I'm moving on here. Now let's go to the next question. Now the next question, which is here, say calculate the magnitude of the normal force acting on A. Obvious, the only object that gets normal here is A, because it's the one that is on the surface. So let's go and calculate the normal force for A. Okay, normal force for A, it is here. So let's calculate normal for A. So this one is question 3.3.1, and we're going to calculate the normal force, right? So now to calculate normal force, we are going to use, this is for A, and we are going to work in the y-axis. Why are we going to work in the y-axis? Because the normal force is in the y-axis. So I'm going to write here in y-axis. Note the following, you don't have to do all this. If you memorize how to do it, you follow the steps, you don't have to do all the steps as I do. All right, this one is to explain, but you don't have to do that. Now, what forces we have in the y-axis, and I'm going to use the same free body diagram. In the y-axis, I have this one here. I'm going to mark now. Those are the forces we have in the y-axis. All right, those forces are the normal pointing up and the gravitational force pointing down. The object is not moving in y. So the correct way to do this one would be by using or applying Newton's first law. F net is equal to 0. That is Newton's first law, because the object is not moving. You don't have to start from there. You don't have to start from there. If we take up as positive, then we get that normal minus gravitational force is equal to 0. That is a 0 there. Let me just erase this one, clean that one there. That is a 0 there. There we go. Okay? So normal is equal to gravitational force, which is equal to mg. When you substitute, we have that is 4 multiplied by 9,8. And this one is going to be, let me move it a little bit up. There we go. It's enough space there. This one is going to be equal to 39,2 Newton. That was the weight of calculating normal. You obviously don't have to do all those steps. If we come here quickly, there we can see that it's 3 marks for that one. So guys, 1 mark will be for starting either point. Any of this one will carry 1 mark, 1 for the substitution, and 1 for the final answer. Those are the 3 marks that you will get in this question here. Okay? I'm waiting to see if there is any problem, any question. Let me come here. Okay, there is not 39,2. Yes, that's what I got. Well done. So let's go to the next question, which is the problem. The next question would be the problematic one. Let me just clean this one quickly, and we're going to solve question 5.3.2. Let me just clean this one because we're going to use the same point here. All right. So there we go. There we go. So now we're going to be calculating the tension for A. Now we're coming back to the free body diagram, and now this time we're going to be working on the x-axis. Why on the x-axis? Because tension, which is the question mark, is in the x-axis. Look here, we're going to work in this axis there, because tension is there, and that is the question. They ask you to calculate tension. Okay, but now the object is accelerating. However, we don't have the acceleration. Okay, so now what we are going to do, we are going to apply Newton's second law on both blocks separated. All right, so we come in here and we say this one is for A, and we're going to work here for A, and here is going to be for B. All right, so we're going to work separated, and we're going to apply Newton's second law on both cases here. So here we got F net is equal to ma. That is Newton's second law. So we're starting from there. We go to the x-axis, and we are going to take here right as positive. It's important also to always select a direction, which direction you want to be positive. So we're going to take right is positive. Okay? So right is going to be positive. It means tension is positive and frictional force is negative. Okay? So we have here that is tension minus frictional force is equal to ma. All right. And we are going to substitute the numbers we have. We have all the numbers for here, but we have 2 unknown. So tension we don't know. We actually supposed to get tension. All right. Frictional force is given to us is 11,76, and this one is equal to 4a. Now we cannot go on because we have 2 unknown. We don't have acceleration, we don't have tension. So we're going to stop here, and we're going to call this one equation 1. This one here is equation 1. All right. So we are going to do the same now. We'll stop there. We're going to do exactly the same for B. So applying Newton's second law on B. But B is moving in the vertical direction. So in this case, we're going to say up is positive. Remember I said try to take the direction of motion when you're working with Newton's law as positive direction, okay? So now here, we come here, let me just look something here, okay? Right, so now here, Newton's second law once more, F net is equal to ma, there we go, there we go. Now, what forces are acting there? We have the applied force, which is pointing up, the force is positive, so it's applied force minus gravitational force is downward, so it's negative. I said up is positive at this point, so it's minus gravitational force minus tension is equal to ma. There we go. All right? We still don't have the gravitational force. Okay? We don't have the gravitational force. Let me just write it here. We don't know this one, but remember gravitational force is equal to mg. Okay? So you may calculate the gravitational force, or you can substitute it here. Because it's simple, I am going to substitute it at this point here. So I'm going to have the following now. If I substitute all the values, go to the question, guys, the values are there. Everything is given to you. The applied force is 96, so this one will be 96 minus m multiplied by g, which is the gravitational force. The mass is 8 multiplied by 9,8. There we go. This one is the gravitational force, or this one here, minus t, we don't know t, is equal to 8a. All right, we can go one more step because we have numbers here that we can actually work with. We have the 96, we have the 8 times 9,8. We can solve those. Right. So if we solve this one, you can do the calculation. I already done it here. We get that part, all this left hand side, will give me 17,6 minus t is equal to 8a. I already done those calculations. You can just compare and make sure you get it like me. Okay. So here, this we have two unknown once more. We don't know tension and we don't know the acceleration. So that one is going to be equation 2. Okay, that one is going to be equation 2. So now we have two equations. Now it's mathematics. There are different ways of solving this one. You can substitute 1 in 2 or 2 in 1. I personally like to add the two equations. Let me see, there is a question. Yes, that's correct, Obakense. The Buru, yes. That's what we did here. Yeah. So now here, let me just make sure. I have to be looking at the question if there is any. Okay. I see Kabetse is very active and busy working with this one. Okay, so now we have to add the two equations. So we are going to write here. Remember to work organized because somebody else is going to mark, your exams. Okay, so you need to be able to work so they know what is going on. That's my coffee. So now you add, I'm going to write here, add 1 plus 2. And 2, I use a Roman number. Let's use the Roman number here. Plus 1 plus 2. Okay, we're going to be adding 1 plus 2 at this point here. Now, when you add mathematical equation, two equations, you add everything from the left-hand side with everything from the left-hand side, and everything from the right with everything from the right. So in other words, you will have, that is t, I'm going to use equation 1 first, so I have t minus 11,76, write it like that, t minus 11,76, that one is from equation 1. Now I'm going to equation 2 here, all right, and I have 17,6 minus t, so this one is plus 17,6 minus t. This one is equal to, now we're going to the right hand side, 4a, which is here, plus 8a, which is there. So 4a plus 8a. Okay, once more, this one is common factor here. So we have that this t cancel because it's t minus t. Even though we are looking for t, the t's cancel, which means we are now going to calculate the acceleration first. And then we can come back to either one of the question and substitute. It's always going to be like this. It doesn't matter if they ask you to calculate either acceleration or tension or force. Either one. You always work here, tension will cancel, then you'll have to go back and substitute. But anyway, this one is simple mathematics. I already done the calculation. You can redo the calculation if you want. And then when you add common factors, this one and this one are common factors, and 4/8 and 8a are also common factors. So you get that this one is 5,84 equal to 12a. All right, there we are. Let me just move my beautiful face little bit to this side. We don't need that corner right now. Maybe here. There we go. Let's leave it there for a second. Okay. So now we're calculating a. All right. So a here is going to be equal to. Let's move it a little bit up. There we go. A is equal to 5,84 divided by 12. You get that a is equal to 0,4867 meters per second square. Meters per second square. There we go. That is the acceleration. Okay, I hope you get that answers. I'm going to look here. I have to be checking if anybody asks a question. No. Okay. Okay. So it's fine. So now we got the acceleration, but the question asks to calculate the tension, not the acceleration. So how can we calculate now the question mark, which in actual fact was the tension? All we have to do here, guys, is to substitute. Let me just do a line here. We're going to answer that in this corner. It's enough space. We're going to substitute the acceleration we calculate in either one of the two equations, either one or two. I'm going to do it in one. So here, one will be t minus 11,76 is equal to, and now we get 4a, but a is 0,4867. Pardon. So this one I'm going to move it a little bit here. There we go, trying to get more space. Is equal to, now there is 4, no 8, writing the one that is right below. There we go. It's 4. And the acceleration is going to be what we got here. All right. I'm going to write at the bottom because it's not fitting here. It's 0,4867. All right. It's at the bottom, guys. It's the same acceleration. Let me just move it a little bit more. There we go. There we go. I'm just trying to show you all the space. And then this is mathematics. This is mathematics. So when you solve this one, you get that t, you move this 11 to the other side, then you get that t is equal to 1,9468. I got that number minus 11, that was rotten h. Oh my goodness. Let me erase a clean there. Minus 11,76. This is 11,76, guys. Do the calculation with me. As I'm working, you can be doing the calculation and make sure my calculations are right. So now t is going to be 13,71 Newton. If this is the answer here, there we go. Now, if you rounded off the acceleration, and I'm speaking about this number here, if you round it off, then this answer won't be 13,71, can go to 13,72 if I'm not mistaken. But I don't like to round off when the calculation is in between the solution. I round off only the final answer. The final answer can be rounded off. Okay, guys, this is the question. Now, marking wise, I know you like to do marking. Let's go to the question real fast. There are 6 marks. So now, where the 6 mark could be here? Obvious. Starting with Newton's second law, we'll have a mark. you all can get that mark. So it's 1. 2 mark for the equation 1 and 3 for equation 2. This equation 2 here get another. So 3, okay? 1 for adding the 2 equations. Not necessarily you always going to get that one. There's 4. 5 for substituting the acceleration you got here in the equation, either 1 or 2, and the final answer will get the final mark. Those are the 6 marks. So now, saying this, everyone could have get in this specific equation at least 3 marks, which is equation 1, 2, and 3. It's not that difficult, it's not that problematic. Guys, this is the end of the question. As I said, I don't want to go too long. I hope you understand. I hope it helped. The idea is to help. Remember, the exams are coming and this topic is done already, so you won't have too much time to go through the work. Okay? So now, it's just waiting. If there is any question, any part that you did not understand, I'll wait for yes, we ate. Thank you. Yes, we ate, Emil, sorry. We ate, yes. I just added there. Here is the addition. Yes. Yes, the space is playing with me in that corner. It's adding. You will get this number. This number is coming from the addition. Yes, you do add. You're right, Emil. Thank you. You move it to the other side. It's negative on this side. So when you move to the other side, it's a positive. It's a positive here. So you add. Yes, you do add. Thank you. Absolutely correct. All right. So now I'm waiting for you. If there is any question. If there is no question, then we are done. You can, I don't know. I move it. I just, because of the space, I'm playing with the space that is difficult with small space, and this one is not the tablet, so I have to manage this space correctly. It's quite difficult to manage the space, so I did the mess the minus the plus there. But this is the idea, you to be active and looking and etc. As soon as I get the test, then I'll give you the scope. But this work will have a lot of marks. This work will have a lot of marks for sure. So make sure to practice. You will have a question of 2 blocks, 2 objects. How is it going to be? I don't know yet, but you will have a question of 2 blocks for sure. The grade 12, same story. Grade 12 will have 22 marks. I got the scope yesterday for paper 1. It's like 22 marks on this topic, and I think you will get around a question that could have 2 blocks because it's more complicated. So this is the question. I hope it helped. Next time it's now entirely up to you. We'll come back now this coming week, and we can organize for next Saturday which question or what question, what topic do you want us to solve a question, because 1 question is enough. Okay. Remember, you can get the question in the description below, as well as the summary. If you don't have it, you can get it in the description below. And then that's it. If you have no questions, then we are done. Then we are done. It's easy. It's better than be at school later, I think. So I'm waiting. If there is not question, then we are done. We are really done. But thank you guys for watching. Try to now go over the question if you think is going to help, and then I'll see you next time.